Hello everyone, welcome to today's video. For today's video, we'll be dealing with coordinate geometry. Now, coordinate geometry is tested, but the actual geometry is not tested. Right, so without much further ado, let's jump into the video. So as for coordinate geometry, we'll be looking at the quadrants of the plane, how the lines, positive gradient, negative gradient, then we'll look at quadratic formulas and a few questions. And so, I'm Clifford Minder, GMAT trainer of the International Scholars Program, and for today's video, coordinate geometry. Okay, so the first thing that we need to understand about coordinate geometry is the quadrants of a plane. There are 4 quadrants, counted anti-clockwise. We start with quadrant 1, and we start with, then we go to quadrant 2 in this manner, anti-clockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Right, so for quadrant 1, the values of x and y. So first thing before we get to that is that each and every point in this Cartesian plane, it's called a Cartesian plane, has 2 values, the values of x and y. So a point in the Cartesian plane has these points, right? That's like a point whereby you give the x value and y value. Okay, so even the origin itself is written as 0 for x and 0 for y. So for each and every quadrant, is x and y positive? X is positive in quadrant 1 and y is positive. Let's go to quadrant 2. Quadrant 2, what about the values of x and y? X is negative, y is positive. Yeah, this is the y-axis and this is the x-axis. Quadrant 3, we have both values of x being negative. Quadrant 4, we have values of x are positive, while the values for y are negative. So depending on the point, you'll just know if it's in quadrant 1, in quadrant 2, in quadrant 3, or quadrant 4. So suppose it hold -5, 2. What about this point? The x value is negative and the y value is positive. That's quadrant 2. Okay, so think of any number and try figure out if it falls in either of these quadrants. Okay, so 4 quadrants of a Cartesian plane. Quadrant 1, 2, 3, 4, counted anti-clockwise. Each and every point in the Cartesian plane has its own x and y value. Now, done talking about the points, let's get to lines. So, normal equation of a line is usually y is equals to mx plus c, or in our case, plus b, whereby m is the gradient or the slope, and c is the y-intercept, or b is the y-intercept. And this is the most common form of the equation, slope-intercept equation. So we usually try and reduce equations to the above form, y equals to mx plus c. Then we also have various other equations. We have point slope, we have the standard form, we have the intercept form, we have the vertical and the horizontal lines. These are equations of horizontal and vertical lines. The slope of a line and the quadrants. So given that y equals to mx plus c, m, which is the gradient or the slope, and c, y-intercept. X and Y are variables. They can take any values, but slopes and intercept are standard values. So if the slope is negative, in the Cartesian plane, if slope is negative, usually have a line going down. These two lines, line 1 and line 2, are or have negative slope. And if not all the cases, even the one going through the origin, let's say this is line 3, will always go through quadrant 2. This quadrant 1, remember, quadrant 2, quadrant 3, quadrant 4. So it should always go through quadrant 2 and quadrant 4. And it can go through quadrant 1 if X and Y intercepts are positive. It can go through quadrant 3 if X and Y intercepts are negative. These are a few of the properties of slopes of line in the quadrants. Then, suppose you have then two lines. This is the Y and the X. These three lines here, line 1, line 2, line 3, have positive slope. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So they must go through quadrant 1 and quadrant 3. Okay, and they can only go through quadrant 2 if the x-intercept is negative, and can go through quadrant 4 if the x-intercept is positive. Okay, so if the slope is 0, now we have other types of lines, so y is x. Okay, so if the slope is 0, then this line is horizontal. This is line 1. That's horizontal. If the line is undefined, or not the line, but the slope is undefined, then this line 2, it is a vertical line. And how do we find the slope of a line? A slope of a line is usually done change in y, or all over change in x. So this triangle depicts change in these values. Right? So let me erase this. And how, say we have 2 points, line goes through point 1 and point 2. Let's have 1, 2. So if we check this out, this will be, let's visualize in almost, if not all the questions, you have to visualize. So x is 2, so 2 should be right there, and 0. So it goes through this point here, and 1, 2. So probably somewhere there. So this line goes that way. So this has a negative slope. And how do we do that? Let's find the actual slope of this line. The actual slope of this line is a change in y, all over change in x. Check. 2 minus 0 all over 1 minus 2. 2 all over negative 1. This gives us negative 2. Yeah, so the gradient is negative. Right. So let's try visualize this again. Positive lines or positive gradients are from lines that increase. Okay, these are positive gradient. You can also have a scenario by the line need not be moved down from left to right. Okay, they need not be like steep that much. So you can have very steep lines that have negative gradients. We have like lines that are almost flat. You can have negative gradients as long as it moves down from left to right, then negative gradient. If it moves up from left to right, then you have a positive gradient. What are the common test areas that you might need to know? You may be tested if you know the relationship between parallel lines. You may be tested also the relationship between perpendicular lines on a plane. So for these two types of lines, they interact with each other in terms of the slopes. So the slopes are the ones that interact with each other, such that for parallel lines, if you have two parallel lines, okay, assume these are parallel lines, then line 1, line 2. This has gradient M, and this is gradient M2. So for parallel lines, M1 equals to M2. That means they have the same slope. You'll mainly be asked to find a point on a different line given the slope of a different parallel line. And for perpendicular lines, so you can have such lines. Yeah, perpendicular lines form 90 degrees when they intersect. So you can have line 1, which has gradient 1, M1, and line 2, which has gradient M2. So the slopes, if you multiply them together, you'll have -1. So what do I mean? M1 times M2, you should have -1. So you'll also be mainly asked to find a point on a different line given the slope of a different perpendicular line. So what are the 3 steps I follow myself? So the first thing is map or visualize, because if you have these points, you can put them on the Cartesian plane and see how the problem looks. Then you need to know how to get the known items that are paraphrasing. What do we know? And you solve for the unknown.
You are watching Success with Bob Mwiti Show, presented to you by the International Scholars Program. The International Scholars Program is an award-winning international education financing scheme that helps bright students to pursue graduate studies abroad regardless of their financial background. You can find our programs by going to www.internationalscholarsprogram.com. The International Scholars Program, empowering dreams.
Okay, so here's a question for us. Let's give it a try. In the XY plane or Cartesian plane, line M passes through point 3, -2, and intersects perpendicularly with the line N that passes through points 0, 3, and 3, 5. What is the equation of line M? We can find the gradient of N, look for the gradient of M, then find the equation of line M. So for the gradient of line N, we can have, so if we were to visualize this, let's draw this first. We have line N that passes through 0, 3, and 3 by 5. So this was line N. Then you have M that passes through 3, -2. And it is perpendicular. Sorry. So need to draw this better. And it is perpendicular. There we go. So for line N, let's find the gradient. Change in Y all over change in x. This will be 5 minus 3 all over 3 minus 0. If you look at line n, you will observe that the line increases from left to right. That means we have a positive gradient. We expect a positive gradient. So for that case, it should be 2 over 3. What about line m? If you look at line m, it decreases from left to right. So expect a negative gradient. Let's confirm. We know that 2 over 3 times the gradient of line m should have negative 1. Therefore, m equals to negative 1 times 3 over 2. And that will give you negative 3 over 2 as the gradient. Therefore, the equation of line m will be y equals m, which is negative 3 over 2x plus the y-intercept c. For us to find the y-intercept c, we know that line m passes through point 3, negative 2. To find c, we input this point, which is on the line, to find c. So we can have x being 3, which will be negative 3 over 2 times 3 plus c equals to y, which is negative 2. For that case, c will be, let's continue, we have negative 3 times 3, negative 9. C will be negative 2, subtract 9, not add 9 over 2, which will be 9 over 2, minus 4 over 2, which is 5 over 2. This is the y-intercept. Now, the new equation becomes y equals to negative 3 over 2 x plus 5 over 2. But if we look at all these other answers, we don't have fractions. So maybe we can eliminate these fractions. If we eliminate these fractions, we'll have all values times 2 will give you 2y equals to negative 3x plus 5. Put every term on one side will be 2y plus 3x minus 5 equals to 0, which is the same as answer A. Okay. Now, here's a DS question. Answer chooses 12, 10, for those who are not familiar. This means for A, the first statement is sufficient. For B, second statement is sufficient. For C, we have to combine the statements for them to be sufficient. For D, each statement independently is sufficient. And for E, neither of the statements, even when combined, are sufficient. We need additional information. So does line y equals to mx plus c intersect x-axis? Does it intercept x-axis? All these lines will have to intercept x-axis except for a horizontal line. Okay. So this horizontal line. So statement 1, gradient of this line is negative. That means the line, let me erase this, the line decreases from left to right. If it decreases, then it will always intercept at x at some point. However, almost flat it is. If you extend the x-axis, it will come a point whereby it intercepts that x-axis. So for that case, this is sufficient. It will always intercept x-axis. Yes, yes, yes. Confident, yes. Absolute, yes. Sufficient. If it's sufficient, then we eliminate B, C, and E. Let's go to 2. The y-intercept is positive. If the y-intercept is positive, yes, for this line, yes, it's positive. It's positive, given this is the y-axis and this is the x-axis. Then yes, all these lines have positive y-intercepts. Also, we can have them being that way. These are positive gradients. Yeah. So all these are positive y-intercepts. So does it always intercept x? Yes, all of these lines intercept x-axis, except if the line is horizontal. This horizontal line has also a positive y-intercept. Therefore, it will never, it's parallel to the x-axis. It will never meet x or intersect x. For that case, for a horizontal line, yes. No, it will never intersect x-axis, but for all these other lines, yes, they intercept the x-axis. So this is not sufficient. If it's not sufficient, then D is eliminated and you'll have A as the answer. Okay, I'd like to finalize the session with a few notes. Mine. Now, we also have what you call reflections lines of lines or on lines. You can paste or you'll have to infer, you need to find a reflection on a certain line. You can guess the what? Reflection on x-axis. So this is the x-axis and this is the y-axis. Reflection on x-axis. If you have a point here, if you have a mirror here, then it will be reflected at this point. Same value for x, but the y value changes sign. So if you reflect 1, 2, same x value, it will be 1 now, and the y value changes sign, goes to that point. So point 1, 2 reflected on the x-axis becomes 1, negative 2. What if this point 1, 2 is reflected on the y-axis? There we go. X value changes the sign and y value stays the same. Now, on y-axis, it becomes negative 1, 2. This for the x-axis, and this is for the y-axis. We also have lines that you can reflect on. Whereby I'll visualize number 3, whereby x goes to y. This line. Sorry. Now, this is a bit faulty. So let's have the y-axis and the x-axis. Then we usually have x equals to y, passes through the origin. Now, if you reflect a point on this line, then the values of x and y are switched, such that if you have a point 2, 5, reflection is 5, 2. Then you also have the last line, which is y equals to negative x. A line going through the origin. Here it is. This is y is equals to negative x, or the other way around, x equals to negative y. and this one is equals to x equals to y. If you reflect on this line, y equals to negative x, the values of x and y are switched and the sign changes. So the same value or the same point 0.25 is reflected on y equals to negative x to negative 5, negative 2. Switched and the sign changes for both. Okay. Lastly, I'd like to talk about the quadratic equations. So we usually say in quadratic equations, we might have no solution. That means the quadratic line doesn't meet the x-axis or intercept with the x-axis, or you can have when it has only one solution, that's when the quadratic line touches the x-axis at one point. Or it can have two solutions whereby the quadratic line intercepts x-axis twice. So usually these lines have lines of symmetry, whereby if you take the highest point or the lowest point and draw a perpendicular line to x-axis, you'll find the distance on one point to the opposites or reflected on that symmetrical line is another point on that parabola or the quadratic line. Okay, so each point also in that parabola or quadratic line follows the same or agrees with the equation of that parabola, such that if you take one solution of x, plug it back in to that equation or that quadratic equation, then it suffices. If you do the same for the other x value, does the same. If you take any other point on that line, it will always agree with that quadratic equation. Okay, and I'd also like to mention a few properties of these quadratic equations. If the value of a is positive, the parabola open upwards, like this. If the value of a is negative, the parabola opens downwards. If the value of a is more than 1, now the parabola is skinny. And if the value of a is less than 1, the parabola is wide. Talking about this equation here, ax squared plus bx plus c equals to 0. And if we put this expression equals to 0, whereby y equals to 0, then we find the solution of the quadratic equation, which is the x-intercepts. So the solutions can be 2 if the quadratic line intercepts x at 2 points, 1 if it intercepts the x-axis or touches the x-axis at 1 point, as I said, and 0 if the quadratic equation or the parabola itself doesn't touch the x-axis at all. So I've done much of talking this time. Hopefully for the next video, I'll have time. We do lots of questions and practice following coordinate geometry. Until there, thank you guys for watching. Have a great day. Bye-bye.